Thank you. Good morning. As already introduced, I'm Mauno Pihelgas. I'm a tech researcher working at the NATO Cyber Defense Center of Excellence in Tallinn, Estonia. And, well, it's great to see so many people here this morning, especially after the social event yesterday. So, I'll first just talk a bit about me. So, for the past 5 years, I've been working as the tech researcher, doing mostly topics related to monitoring and also a bit on data mining and machine learning. Before that, I was working as a monitoring administrator for the largest Estonian telco, which is now acquired by Telia, but before that it was a local Estonian one. And that work was mostly sysadmin work, but also bordering on something like DevOps style, so doing your own scripts and stuff. And I'm also doing my PhD. This sounded like a good idea 4 years ago. I should be graduating already, but there's still some things to do before it can actually happen. But okay, my talk today, it's about an exercise called Locked Shields. Are there any people who have heard about it in the audience? No? Okay, that's good. Well, I won't be boring people, hopefully. And I'll be first introducing what the exercise is about, and then also talk a bit about the technical background, how I've set up the monitoring system that does the availability scoring in the exercise. I'll also touch a bit on the challenges that I've faced over the past 5 years that I have been building this system, and also what kind of visualization tools we have come up with over the years. So that's the new logo. And, well, Locked Shields in numbers, we are saying that it's the largest international cyber defense exercise. I don't know if it actually is, but with 1,000 people involved, I guess it's definitely one of the largest. And we have I think, pretty much all NATO nations contributing to the exercise, as well as some other non-NATO nations that are contributing partners. And in 2018, we had 22 blue teams. Blue teams are the target audience for the exercise. So they try to defend their systems that we provide them. And there's one red team that is doing attacks against all those blue teams. And there's slightly more than 100 unique attacks against each of the blue teams. And that totals to 2,500 total. And for the exercise, we usually deploy around, or at least last year we deployed around 4,000 VMs, out of which slightly more than 300 were the blue team systems that are scored during the exercise. The gameplay lasts around 2 days, so 16 hours, 8 hours per day. And the exercise, it's a competition between blue teams. And there's one winner declared, and it's definitely a lot of fun and a great experience for the participants. So, I already listed some acronyms, and just for brevity, I'm gonna put a small glossary here. So, yeah, there are all types of different teams involved, and I don't want to always write them out long, so. And the exercise it's a fictional scenario, and it involves around a fictional country called Beryllia. And it's somewhere in mid-Atlantic. And what happens is there's an aggressive nation called Crimsonia that has launched a cyber attack on Beryllia, and now Beryllia calls all NATO allies for help. And nations send in their rapid reaction teams to respond. I already mentioned all different teams that are involved. So we have green team that does the infrastructure for the exercise. There's a white team that does the overall exercise control and handles how the scenario flows and does media injects and handles communication. Then yellow team provides situational awareness. So they get situational awareness from blue teams and red team and provide it to white team and vice versa. Of course, red team does the attacks against the blue teams who are supposed to defend their systems. So I've also took a couple of videos. They're also available on YouTube, but I'll just do them locally here. So there's two of them. This is from last year. This is about how we set up the exercise. So it's not something we buy in. It's really, we build the stuff ourselves. We go in a few days in advance, start setting things up. So for example, there's a TV wall, and it's again something, you know, two guys went to the hardware store, bought their stuff, bought 25 TVs and just built it. And so it's definitely something that requires a lot of work and love over several months before the exercise actually takes place. And maybe I just like the video because I'm also in it. And we're not doing this alone. We have a lot of partners from the industry. For example, there's an Estonian drone maker. They're making military-grade surveillance drones, and they brought in their flight controllers for the blue teams, and then they also get to demo their actual drones during the exercise. Okay, I'll show the other one as well. This is now the execution of the exercise. This is from this year, in April. So you have typical cyber exercise where everybody's just sitting at their computers, typing away. It's hard to make it interesting if people are just sitting and typing. Yeah, we do get a lot of VIPs also for the exercise. They want to see what we're doing. So they come in, they get briefed before they go to the control room. And in the control room, there are a lot of different tech that has come in. So for example, this year we had Ericsson. They came up, they brought their 4G base station, set it up in the hotel, and each of the blue teams got a 4G access router that they had to defend during the exercise. I also already mentioned the drones. The lady in the white suit is the Estonian president. She's getting an overview of what is happening. For example, yeah, Siemens provided us with the power grid, a mock-up power grid, and so yeah, there are a lot of partners involved. Siemens has been helping us for the past 3 years, I believe. Ericsson was added this year. And yeah, and there was also the water purification plant. And if that got hacked, then there was too much chemicals in the water and people would get poisoned. That's a big problem. And also, as you can see, each of the blue teams got their own water purification plant, so it's actually a challenge for many of the companies who want to come in and contribute to lob shields. So we tell them, hey, if you want to come in, you have to bring 25 of your controllers or your PLCs, or so it's not just 1 or 2. So each blue team has to get their own system. And yeah, blue teams are not on site. They usually connect in via VPN from their home nations.
So thank you. Over and out.
But some nations, I mean, they take it seriously. They take their team and they fly in 1-2 days in advance. And so to make it more realistic, actually being on site. But so, okay, I've spent around 10 minutes introducing the exercise. Let's go ahead and talk about the main topic, scoring. The availability scoring is just one part of the overall exercise scoring. So the red team is conducting their attacks, and if they get a successful attack, the blue team loses points. If the blue team keeps their systems up and running, so the scoring system that I'm building thinks the services are okay, they will get positive points. And these roughly balance out. So the blue teams have to make a decision if they keep their systems available or if they maybe close them down, firewall them, or whatever other means they protect them with. They will lose availability, but they're likely to get less attacks from the red team this way. And then there's also other types of scoring. There's a forensic challenge. There are scenario injects, media injects, and blue teams have to respond. And if they do a good job, they get points for this. But this talk today is just mostly about the availability scoring, so it would actually fit this conference as well. And the availability scoring, it basically just monitors all the blue team systems to see if they're available, if the blue teams haven't blocked the required services that they're supposed to keep running. And I've usually done this with approximately 5 VMs in our cyber range. 3 of them are Nagios Core boxes, just positioned at different points in the network. One is external, then there are internal ones, and the other ones for just the management network. There's also a Selenium box for monitoring web targets to see if the websites are actually functional, so if the users can log in, or because something that typically happens is the blue teams, they just make the website static. So they save the HTML, but lose any database connectivity in the back end, or turn off some features that are supposed to be there. And the 5th box is for checking. There's a custom agent on the workstations on the blue team systems, and it's supposed to call home to us to indicate if there's actually outgoing connectivity is allowed. And this has to be true for both IPv4 and 6 in order to be successful. So you might be wondering why Nagios. I've heard a lot of bad rep about Nagios the past few days, and well, I mean, the Nagios Core, it's simple, it's small, it's easy to deploy. I mean, I was working with Nagios before that, and I can probably just compile Nagios in my sleep. And well, I was looking at different tools. It's like, I don't really need some business process monitoring for this, or some dashboards or stuff that typically work for an enterprise monitoring. So yeah, if I would be setting up an enterprise monitoring, I definitely wouldn't go for Nagios. But for this, at least for me, it worked perfectly. So I've kind of illustrated how the data flows. So the scoring servers check the blue team systems, and then all the 5 machines push their output to Apache Kafka. That nicely produces a feed, continuous feed of the scoring check output. And there's again a custom Python program that does the score calculation. So it basically calculates the SLA and takes some mathematical function how it actually gives points for uptime. And this gets pushed to the yellow team and white team dashboards, so the one that you actually saw before with the scores. And for ourselves, for information and debugging, I'm also just pushing this to Elasticsearch and looking at the logs with Kibana and creating my own dashboards in there. As I already mentioned, in 2018 there were slightly over 3,000 hosts that I was monitoring, and in total they had like 31,000 services. What makes the number also so high is that I'm checking IPv4 and 6 separately as services, so they both have to work. And it's not just, okay, if your website is up, but I want to know if it's up on IPv4 and 6. And I'm also doing this with a fairly short check interval. So it varies between 40 seconds to 60 seconds. It used to be even lower, but then some infra guys came to me that, hey, let's just put it a bit slower. And I'll talk a bit on this later as well, but I've varied the check interval intentionally, because otherwise, like the monitoring is like a heartbeat. If you have it set to 1 minute, it comes like tick, 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 just exactly every minute. And it's super easy for blue teams to check their logs, and you see like Nagios coming in every minute. So I'm just varying the interval every now and then, and just making it a bit harder to identify the monitoring service. But for 2 days, I'm logging all the check outputs, not just state changes, but every check output that is run. And for 2 days, I'm getting like 34 million log lines. It's not all that much, but still something, considering that they're mostly active checks that I'm running. And so it's like almost 600 checks per second that get executed, so it's fairly okay. And how I've set up the logging all the service check outputs. So in Nagios config, there's the possibility to assign a service perf data file. Well, it's meant for perf data, but you can have your custom template, and you can put whatever in there. So I've made this short, compressed format. I'll just show what it looks like on the next slide. So there's the host name, the service, the status, the output field, and 2 timestamps. One when the check was executed, and the second one when it finished, just to get the duration of the check. And this gets pushed to Kafka and handled from there on. There's also, I know there are better solutions than Nagios configuration files out there to manage your configuration, but I'm not doing this separately for all blue teams. I'm just having one master template, with some placeholders for team numbers and domains and IPs. And then I just run my own script that duplicates this configuration file into the actual configuration file for the specific blue teams. So it's a simplified version of it, but it's basically a for loop, converting the team number to double digits and copying the template and just running sed to do all the replacements for the team numbers. And it has worked until now, so there's no need for anything fancier. So with the exercise, there are also quite a few challenges that you wouldn't encounter in your normal enterprise monitoring. Because it's sort of, the blue teams are like the enemy. They're trying to show you that all their systems are always up and running. And they're trying to make sure that, you see as good a picture as possible. And they're using various techniques for that. So over the years, I've encountered teams, actually taking down their service and running port spoof on the ports that they're supposed to, or the services that they're supposed to keep up and running. And if you're just using check TCP, they will get away with it. But it means you have to actually check if it's supposed to be an SSH service. You have to try to log in and see if there's actually a machine behind it. And it's not just a netcat or port spoof listening on the port. Or some redirection tricks. So you're going to a website and they're actually redirecting you to another website that is up and running, always. And you're not actually checking the one that you're supposed to check. And you don't encounter this in a normal enterprise situation that the sysadmin is trying to trick you that their systems are up and running while the server is actually down. Well, maybe sometimes, but and this is why I haven't really gone the way of using host-based agents in monitoring, since I think they're susceptible to manipulation in a way that those are like real experts there, so they can do reverse engineering on the agent, or they will use some man-in-the-middle tool to just start sending me the results that they would like me to see, instead of the actual agent sending me the results. But yeah, we still have this outgoing agent, but we have really customized it so that it just connects to one web service. From there, it gets another IP that it's supposed to connect to, then connects it there. From there, it gets a third IP that it's supposed to connect to. And so it's more of a cat and mouse game with the blue teams to make sure that they haven't manipulated the agent in any way. And, well, I already told that monitoring is fairly easy to detect if it's based on the interval or just how it behaves. It just comes in, doesn't do much, checks if the service is running and goes away. So it doesn't really act as a normal user. So blue teams often tend to use whitelisting for just allowing the monitoring. But if you check from another workstation or another IP, it's actually blocked. And for this, I wrote a small script that just basically does DHCP release, gets a new IP, and this also for both IPv4 and IPv6. And it does this at a semi-random interval, so it just put some numbers in cron and for this, you cannot really do it while Nagios is running, since there's 600 checks per second. It will definitely give you some false results in this way. So what I'm doing is shut down Nagios, wait until it's shut down, change the IPs, and then start, well, change the IPs, make sure the connection is actually working before you start Nagios, and then once you have made sure, then okay, bring it back up. It usually gets this done in something like 5 or 6 seconds, so it's pretty okay. Then there's one other thing, how the blue teams can identify the scoring server. So the most notorious one being the check HTTP with its user agent. I mean, it's really easy to see from the web server logs. Yeah, okay, check HTTP came in. And in your normal situation, you don't really care. It's really good to see from the web logs that, oh yeah, it's the monitoring that is coming back every minute or every 5 minutes. But yeah, I know I can change this from the command line arguments, but I just went in and compiled in a new user agent, so it's just always something like Firefox instead of being the check HTTP. Same with the check SSH. When the client connects to the server, it sends its identity string, and it just reveals on the network that, hey, okay, check SSH came in. And the final one, there's check SMTP. I wasn't aware of it until a few years ago. I started looking at the PCAP captures that were taken from the exercise, and it's like, hey, what is this? So it's not telling like on check SMTP, but it's sending the host name to the mail server. And my host name was like scoring2.ex. Yeah, it's like a nice giveaway for the blue teams to see where the scoring server is actually coming from which IP. So yeah, I changed that to something, I think there's like something like a rogue workstation, or not rogue, but mobile workstation that's connecting from the internet to the blue teams. I changed it to that host name, and yeah, haven't seen any problems after that. So I also mentioned having different network vantage points. But what makes it more interesting is that we have 22 identical networks. And so this is something from 2015. I used an old network map. So if this ends up being on the internet, we don't really care. So it's fairly complex. I mean, the blue teams have something like 8 or 9, even up to 10 VLANs that they're supposed to protect. But if I want to have an internal view into that subnet, I have to put one interface of the scoring engine into that subnet. For example, the int. So if I want to check if the domain controller is actually working, I cannot do it from an external IP because that doesn't just make any sense. So I have to be in the network. And yeah, for this, I'm setting up this trunk interface, and I put a VLAN tag on it, and I can just be virtually in that network. And if you're considering different VLANs and how many blue teams there are, it sums up to something like, I think this year I had 150 network interfaces on that scoring machine. And it actually takes something like 6 minutes to boot up the machine, since it's doing IPv6 neighbor discovery and all that stuff. So yeah, there's some weird stuff you start to see. And the ARP and the neighbor tables are too small, so I think they're by default only like 100 ARP entries, 128. And if you have like direct connectivity to 1,000 machines, you have to actually really increase the ARP table size. And well, finally, Selenium is a really powerful tool, but if the blue teams modify their websites even in a tiny way that doesn't really change anything in the UI. Maybe they change something in the code. It will just break the checks. So we really have to work hard in order for the checks to actually work throughout the exercise. We're still having some troubles with that. But yeah, we're working on it. Hopefully this next year it will be better. And there's also Blue Team setting up their web application firewalls in front of the websites, and these also tend to block the monitoring sometimes. Okay, I also wanted to talk a bit about the visualization that I've set up for the exercise. And, well, as you all might know, the Nagios default user interface, then the core one, I don't know about the XI one, but the core one is just horrible. You cannot really use it for anything if you have more than I don't know, 50 or 100 hosts. But what makes a good visualization? So it needs to give you a great overview, but when you need to dig in or need some more details, there has to be a drill down functionality. So if you want to actually see what the output from the check was, you don't want to go into logs digging in. You just want to click somewhere and get the information. And what many visualizations lack, they just give you the current state. You don't see what happened 5 minutes ago or what happened an hour ago. So this was something I really cared a lot about. So this is sort of a process that I was working through starting from 2014. So I got some inspiration from the Nagios grid view, which I think is the best one there is. So it's compact, shows you a lot of information. And I already told that the blue teams have the identical setup, so they all have same hosts. All the hosts have the same services. So I can just line them up. And on the left-hand side, these are the hosts. In the top, the columns are the blue teams. And within each cell, you have the services. And it gives a really good overview. And if you see problems, for example, there's like with one row, there's a lot of red. I think I have a better one. So there's a lot of red. And this indicates that many of the teams are having a problem with that host at the same time. So it's either during the game, perhaps the red team was attacking and they managed to get most of the teams, but not all. Or if it's before the exercise, even the green team infrastructure guys, they're constantly going here to look if they deployed, for example, the domain controllers. They want to see if all of them are working for every team, because even if you're cloning machines, there's always like 1 or 2 machines that for some weird reason fail to deploy correctly, and you just have to do them all over again. And if you're seeing something red in a vertical line, then it's probably just the blue team messed up their own networking, for example. But still, this is really good for overview, but this doesn't provide history. And I'm not constantly sitting in front of my computer to see like what is the current situation, and the exercise is hectic, so there's constantly things changing around. So I was like, I want to also see the history. And I think it was 2015 when we started working on it. So I called it Service Measurement Map, but the developer, a Spanish colleague who was working on it, he dubbed it just Log Shields Monitoring. And, well, this is what it looks like. It's a bit stretched out to give give more. But what you have is on the top, it's the timeline. Each element or cell is 1 minute bucket, and there can be more than one check result in one bucket. So if there's, for example, one OK status and one critical status, it's not green anymore, it's just something in between. So you can have those like transitional colors as well. And yeah, okay, I didn't mention, on the right-hand side, these are all the services. So you get the service, the time, and I don't know, I like it. The developer who was saying that it's too small, you cannot really read what are the services. I was like, well, I know what the services are. I don't need to read them because I typed them in myself, so I know what they are. I just want to see the patterns that are being created over time. And I guess it's probably similar for network operation centers as well. So if they're looking at a picture 24/7, they know what is there. They don't need to actually go in and read all the time. What is the host name, or what does this group mean? They already get this knowledge just by looking at different regions. And I mean, if you zoom in, you can actually read, but if you zoom out, you cannot read or click. Oh, and yeah, if you click, you see the actual check outputs of the current block. So if there's 2 check outputs, you will see what the output was, what was the message, what was the status.
Is this a map for one blue team or?
This is for one blue team. I want it for all, but on. Yes, it's actually on the next slide. I'll just cover this one, and then we talk about the problems that it has. So it's a web application, HTML5, JavaScript, uses WebSockets to fetch updates from the server. And yeah, it also subscribes to the same Kafka instance that we were using. And yeah, I mean, it's fairly simple, but it gets the job done. And I was looking at the Refocus presentation yesterday, and they were also just going, let's just use colored blocks to show the state of services. So if you want to drill down, you can drill down, but if you're looking from afar, you just want to see if there's something wrong or not. And yeah, okay, color coding, if you've ever seen Nagios check output, you know the colors, green, yellow, red, orange. And I think one significant one, so if there's no measurement for 1 minute period, it's just a black square. Makes sense. And I was talking about the patterns. So these are the maps for 2 different blue teams. The one on the left didn't do as good of its job as the one on the right. But what I wanted to point out was, you see those blue arrows showing that this vertical pattern. This was actually one of the routers failed in the infrastructure, and this pattern was observed for all blue teams at the same time. So this is actually something I care about when I'm running the system. So I don't really care about those like small stuff here that's just for one blue team, but I care about if there's something really wrong with the system or with the infra. And I'm working to improve that, to actually just filter out those things that would be common for all blue teams, or at least a majority of blue teams. This functionality is not there yet, but we're improving it. And well, problems. It's huge. I mean, for 8 hours and one blue team, you get something like almost 300,000 of those elements on a page. And considering that there's even more checks behind those elements, it's just a lot of information. And yeah, I had some heated discussions with the developer how big one cell should be. I wanted to go smaller. He said, no, you cannot go smaller. I think in the end it stayed something at like 7 pixels square. And in the original size, if it's like 100% zoom, it's something like over 4,000 pixels times 12,000 pixels, which is a lot. It doesn't even fit on an 8K display, let alone 4K or something. But I mean, if you fully zoom out to 25%, you can almost fit it on a full HD display, which is fine. And future work, we want to develop the map further, so it would actually, okay, it would have the same ability, but also to just better detect those common mistakes that affect all blue teams. So if there's something I have to do to fix, or if there's something that the infra guy should do, because if there's just some like small noise, I don't really care about that. It's probably the blue teams messing up their systems or the red team doing their attacks. But yeah, if there's something bigger, then I care about it. And well, over the past 5 years, I've collected quite a bit of data. I've stored all the logs. We have all the PCAPs from the network. We have the scoreboards. So what I would like to do personally, or at least the researcher in me would like to do, is do some machine learning or something cool with the data that would, perhaps we can predict a winning strategy for locked shields. So something like, okay, if you do this in the beginning and then switch to the other strategy, something like a winning combination. I don't know, maybe there is such a thing, but we just haven't had the time to look into it. And this concludes my talk. Thank you. If there are any questions.
Hey, that's cool. Could you give us a bit more detail about the Selenium, sort of how you make that work as a plugin? What were the challenges there?
Well, I've mostly been just a co-developer for the Selenium. There's one other guy who has been building it mostly. But what we're doing is we're doing the test case. We're exporting it to Python and then running it on a headless Linux machine. There's different web drivers that we've tried over the years, so Phantom.js being the most common one. We've tried Firefox and Chrome, but with Firefox there was the memory leak issues, so try running like 20 different ones in parallel and you'll soon run out of memory. But yeah, this year I got a new web developer who's trying to help us out with the Selenium, and hopefully he can make those test cases a bit more solid when he works with both the web target development and then also building at the same time the test cases for the Selenium. There's one at the back.
Have you been, as a monitoring guy, like a target of attacks from the red team? Like they're trying to go over the monitoring server and manipulate the state? Is there something like happening?
Yeah, sort of. I don't think they've ever used the monitoring server as a hopping point. They definitely could, but we're always telling them that scoring is off limits. It's something that the green team handles and don't touch it. But they're still, I think 1 year they were injecting their malware in the scoring bot agent, for example. That was a few years ago. And what they're always trying to do is, so there's a scoring bot account on the system, and they're doing something like scoring_bot account. So there's just like doing things that look similar, but not necessarily are the actual scoring bots. So they're walking on thin ice, and we're telling them, please don't do it. But there's still someone who's trying to be smart. And but you also had a question if I've been a target. So that's a funny question. So it's mostly with the Selenium. If you see that the check fails, you have to go in and check the website yourself. But quite often the websites are already infected with some malware. So it's like you're using your disposable VM for going to the website just to see if it's up and running. You definitely, maybe just want to delete the VM after the exercise is finished.
Hi. I've played a couple attack and defense, capture the flags, and there the monitoring is also very antagonistic, and the organizers run into the same problem that people like to cheat. Usually the ones who try to cheat don't end up on top because they spend so much time on cheating that they don't score any points. Nevertheless, it would be really interesting to have a write-up of the common issues with people trying to cheat the scoring system and monitoring. Is there something like that?
Well, I actually did write a paper. It was sort of like this academic style, not very practitioner-oriented, but I mean, it does sort of describe what I was also talking about here. It's not published yet. I've sent it to a conference, but hopefully in the beginning of next year, if it gets accepted to the conference, there might be a write-up of this, what I was talking here, in a paper form as well. But yeah, I do agree. And even if we're like describing the scoring, we're usually not very descriptive, even for the blue teams, because if we tell them exactly what we're doing, how we're doing it, we feel that the more information we give them, the more they start abusing the system. But I do understand from a blue team perspective, it's problematic since they're, hey, there's something coming in, I don't know how it works, what it does, it's just like monitoring me and giving me a score. And this is also why during the game, I think the scoring is getting the most blue team tickets, like issue reports, throughout the game. So it's a problem.
Thank you.
I think that's it. No more questions.
Thank you very much.